So I'll put my presentation. So this is Prescan, the user interface. I just start a new experiment. And there's a library here on the left with all kinds of elements that I can just drag and drop into the build area. You see that all the elements start with making some infrastructure. Roads, they all connect automatically to each other. Each element of Prescan has many parameters. For example, this roundabout is 2 lanes, I can make that 3, and you see it updates automatically. Radius is 18, I can make it 25, so it becomes bigger. All the other elements change along automatically, so I make a 4-lane entrance road here. You see that the roundabout also gets 4 lanes here. If I take a curved road, 2-lane, I approach the 4-lane zone. It becomes 4 lanes as well, and then you can further adapt the curvature, either by dragging and dropping or just filling out the values right here. But that's infrastructure. I can put road markings on the road. For example, here a zebra crossing. With some buildings. These are standardly available buildings, but as I said before, you can import any 3D model into Prescan. Abstract objects, some trees. Traffic signs. 4 sets are available: Dutch, German, Japanese, United States. So since we have a Japanese guest here, put a Japanese traffic sign here. See, all the Japanese warning signs are here. Regulation signs. Let's see, to do something. Guide signs. I don't know what this means, but or something. Does this make sense or not? Yes? But stop. Very good. Move up and down. Number of actors, cars here, motorcycle, truck. For import actors, I can make routes, free draft routes, for example, like here. And then just drag and drop an actor on it. And if I then run, you see the actor drive the trajectory. Default speed is 50 meters per second, but of course I can adapt that. Here's the speed profile, it's 50 meters per second in time, but I just adapting this control points, you can make any speed profile you want. It's free drafting. Sometimes it's useful to let the trajectory be inherited by the infrastructure, so I just click a couple of starting and end points and assign this vehicle to the new trajectory. If I run again, you see it runs on the infrastructure. I can still convert this inherited path to a manual path and just tune and tweak it. Okay, to make the scenario a little bit more interesting, let's add a second vehicle. Drives from here to here maybe. Two vehicles driving. It's not very interesting still, it's not very dangerous, so we stop it. We can drag the vehicles over their paths to make, for example, this situation that we want to have. Push the button synchronize trajectories. Make one of the vehicles a reference vehicle, and if I then run again, you see that the blue car here waits until the red car has reached a specific position, so that exactly this situation will turn up. It's not an accident, but it's critical enough to work with sensors. Open the sensor menu, here are the available sensors: antenna receivers, transmitters, infrared beacons, onboard units, radio beacons, onboard units. Camera sensor, both mono vision, stereo vision, color, monochrome, and the so-called TIS sensor, which can be either a radar or a laser scanner, depending on how I configure it. So let's maybe add a laser to the vehicle. A whole bunch of laser parameters that I'm not going to go into depth because I see Anton already looking on his watch. So just the default laser and maybe an antenna transmitter on this car as well. I built, this is all pre-processing. I go to MATLAB Simulink and I open the compilation sheet, which is the MATLAB Simulink representation of the scenario that I just built. It's generated on the fly here. You'll see the two actors in my scenario. They both have inputs and outputs. Inputs is a GPS receiver, standardly available. The red car here also has a laser scanner. And both cars output their state to the simulation, and the red car has extra output, that's the antenna transmitter. If you click the car open, the state of the vehicle directly follows from the trajectories. Here you see sensor inputs, and using all the standard MATLAB Simulink building blocks, I can use these sensor inputs to build any controller that I want here to do something with the state of the red car, or you see the antenna transmitter. Maybe you want to send away the range here detected by the laser in one of the channels on the antenna. So you can send that to other vehicles. I'm not going to model the whole controller here, just put a scope on the laser to show you, give you a sense of the outputs when I run it. Simulation time 10 seconds maybe, and just press simulate in Simulink. Takes a couple of seconds. 3D visualization opens up here. Here we see our scenario, and here we see our scope. These are the first array is the samples 1 to 5 every time, and when the cars approach each other, you see that the second one is the range. So first detection was at 35 meters here, then there was no detection, and it drops till 5 meters. They're following each other now with constant distance. And this third graph is the azimuth angle of where the detections were. First we were at the right side of the vehicle and at the left side. Okay. That was a very short demonstration. One more slide, my PowerPoint. Just very generic perspective. The benefits of Prescan allows for fast and cheap design iterations. So if you want to change parameters in the real world on your real prototype, it might be time consuming and costly. Prescan is all simulated, so you can do it very easily. Another benefit of simulation is that you can both control and quantify the circumstances. Out in the real world, you don't have any control over the weather, for example, or light circumstances. Position heading of other vehicles, control is difficult. And also quantifying. It rained during our test, but how severe was the rain? Nobody knows, nobody has measured that. In Prescan, you can quantify that. Very obviously, you can use Prescan to test your system in dangerous situations. Nobody gets injured or dies in Prescan. And the end goal is to make sure that physical prototypes are first time right. So in the end, you still need to go to the road, but ideally that's only for confirmation that you've developed everything perfectly. You don't want to develop on the road. That was my presentation.
Thank you very much.
Did you feel the demonstration was too short? Please,